Panning.
Okay, you're right.
I just don't know what I did.
It didn't hurt.
Just kind of, no, it just feels like a
Well, like,
scratch on
when
the
Okay.
Panning.
Oh, okay.
Okay. We've all heard of the story of the birds and the bees, of how a man and woman love each other enough, they create a child. But as we've gotten older, we've realized the process becomes much more complicated. If a couple wants to conceive naturally, sometimes it doesn't work out, and so they must refer to assisted reproductive techniques such as in vitro fertilization. There's been groundbreaking research in three-parent in vitro fertilization. The UK has approved the next phase of testing, and now there are grassroots in America to have this testing take place here. I've researched medical journals and want to share my findings with you about this incredible research. Three-parent IVF is a developing procedure that has the potential to prevent incurable diseases, but the ethical issues and procedural uncertainties make it a controversial topic in the medical community. First, let's look at what three-parent IVF entails. Sarah Norcross is a commissioner of BioNews, published an IVF article on February 23, 2015. IVF is when a sperm and an egg are harvested and artificially inseminated in a laboratory. So three-parent IVF is an extension of IVF and is also known as mitochondrial donation. This can be executed in two ways. First, maternal spindle fiber transfer. This is when a couple, let's say a couple wants to conceive, a couple's egg and sperm are harvested, and the nucleus of the initial egg is taken out of the woman and put into a donor egg. The donor egg is then harvested with the man's sperm. Then the embryo that's resulted is put back into the woman. So 3 parties are involved. The other type is pronuclear transfer. This is where the couple's egg and sperm are harvested, but then the sperm and egg are harvested and then inseminated, and then that nucleus of the resulting man and woman are put into the new egg. So either way, 3 people are involved in the creation of this new embryo. With experimental unknowns, some in the medical community support it because of the foreseen benefits. Newcastle University, which is located in England, has a Trust Center for Mitochondrial Research. They published a question and answer in 2015 explaining some of the problems and some of the effects of mitochondrial diseases. The ability to prevent mitochondrial diseases such as ALS, Lou Gehrig's disease, and muscular dystrophy can be used through this new technique. First, we must understand the mitochondria. The mitochondria is an organelle within the cell. That means it's a little small organ inside of a cell, and it is the powerhouse of the cell. This means that it produces 90% of the work that the cell does. Mitochondrial DNA takes up 1% of the regular DNA, so 99% come from the nucleus and 0.01% come from the mitochondria, which they're saying is not related to being unique. And your characteristics such as like hair color, eye color, all your features do not come from mitochondrial DNA. But the mutation failures, such as when the mitochondria fails to produce enough energy, results in the diseases such as ALS, Lou Gehrig's, and muscular dystrophy. The Telegraph, which is a UK newspaper, somewhat like the New York Times, published an article on February 3rd, 2015. It said that 770 babies in the US could be prevented from contracting a mitochondrial disease if this new technique was used. Because mitochondria are located in every cell in the body except for the red blood cell, they're virtually incurable unless they can be prevented. So, with all the amazing benefits of this research, what's holding us back? The main issue is ethics. Anik Tavar recently wrote an article for the BMJ, which is a specialty journal which specializes in journals on global health care. He raises a question about it creating designer babies. Because there's an unequal connection between the nuclear and mitochondrial DNA, he doesn't know the effects of we won't know the effects of how mitochondrial donation will happen until it's actually done in humans. That 0.1% of DNA from the mitochondria versus the 99.9% in the nucleus, we don't know until we do it. He also writes that it's a slippery slope. GMOs are such as food, which we eat all the time. We eat corn that has been genetically modified to have a sweeter taste, to have bigger kernels, to grow faster. We eat those all the time, but we're saying now we're going into genetically modified humans. Is it ethically right to change the genetics of a human, even if it's for the betterment of society, or so people say? So overall, robust regulation is advocated because we don't know the effects. Three-parent IVF ethical questions can only be answered based upon your own worldview and how you view the embryo and how we're supposed to manipulate it. Three-parent IVF is a treatment option that has enormous potential, but the ethics surrounding it make people hesitant. Because research has been taken the next step in the UK and the House of Lords has approved the next step of research, maybe in 50 years, your grandchildren may have 3 parents.